Hello, welcome to Mole Conversion Made Easy. In this video, we're going to learn how to do mole conversion for compound, how to calculate the molar mass of compound, and how to do mole conversion for compounds. But before we jump into all that, you might be wondering, what is a mole? Well, there are lots of different moles in the world, but in chemistry, a mole is a large number of things. It's kind of like a dozen, only bigger. 1 dozen is 12 things. 1 mole is 6 to the 23rd things. That is 600 billion trillion things now. That's a lot of things. But why is the mole such a big number? Because atoms are so small. Suppose you wanted to know how many hydrogen atoms are in 1 cup of water. If you were able to count all the atoms, you would find that there are about 15 trillion hydrogen atoms in a cup of water. But if we count using moles instead, that works out to be only 25 moles of hydrogen atoms. So we use moles to count atoms, molecules, and other chemicals.
It turns out that there's an even better reason why 1 mole equals 610 to the 23rd things, and that is that 1 gram equals 610 to 23rd atomic mass units. Let's see what that means for a particular element. Break out your periodic table and look for lithium. It's the third element in the bottom of the square. You should see the number 6.94. This is the atomic weight of lithium, but is also the molar mass of lithium. So 1 lithium of atom has an average mass of 6.94 AMU, and 1 mole of lithium atoms has a mass of 6.94 grams. That gives us a convenient way to count atoms by weighing them, and the molar mass is the conversion factor between grams and moles. Let's try a problem how many moles of lithium are in 25 grams of lithium. This is 1 step moles of lithium are in 25 grams of lithium. This is unit conversion problem, and like any unit conversion problem, the first thing you should do is write down the quantity you know.
1 mole lithium equals 6.94 grams. Because we started with grams, we put 6.94 grams on the bottom of the fraction grams. And the top of the bottom cancel each other out. Next, write 1 mole in the top fraction. Because the 1 is on the top of fraction, this becomes a division problem. In your calculator, type 25 divided by 6.94. The answer is 3.6 moles of lithium. You may have been wondering what happened to the E in mole. Well, it turns out the abbreviation of mole is MOL. Isn't just wonderful how much energy we're all gonna save by not writing the E? Okay, time for another sample problem. What is the mass of 11.5 moles 11 lithium? Before we solve this problem, we realize the mass is measured in grams, so we need to convert from moles to grams. The first thing you should do is write down the quantity you know.
11.5 moles of lithium. Next, multiply this by conversion factor fraction. The molar mass of lithium is still the conversion factor. Because we are starting with moles, 1 moles goes on the top and 6.94 grams goes in the top mole. In the top and bottom, cancel each other out because 1 is on the bottom of the fraction. In your calculator, type 11.5 times 6.94. The answer works out to be 79.8 grams of lithium. That is how convert between moles and grams for elements. But what molecules and compounds? Let's start by looking at molecules made from carbon, nitrogen, and oxygen. The molar mass each element is typically written on the bottom. Now, in order to convert between grams and mole for molecules, we will need to calculate the molar mass of the molecule by adding up the molar masses of all the atoms in the molecules. Let's try few examples. Carbon monoxide has 1 carbon and 1 oxygen. So we add 12.1 for carbon and 16 for oxygen to get molar masses.
To get a molar mass of 28.01 grams per mole in general, the units of molar mass are grams per mole. However, it is very useful to write the molar mass as an equality. 1 mole of carbon monoxide has a mass of 28.01 grams. That helps us remember that the molar mass is a conversion factor. Let's try another molecule. Nitrogen is a diatomic element composed of N2 molecules. Because there are 2 nitrogen atoms per molecule, we multiply 14.01 by 2. So the molar mass of N2 is 28.02 grams per mole. For carbon dioxide, there is 1 carbon and 2 oxygen atoms, so we add 12.01 for carbon and 16 times 2 for the 2 oxygen, which gives us a molar mass of 44.01 grams per mole. We can do the same thing for ionic compounds like magnesium nitrate. The molar mass of magnesium is 24.3 because there are 2 nitrates in the formula. That means we have 2 nitrogen atoms and 6 oxygen.
6 oxygen atoms, so we had 24.3 plus 14.01 times 2 plus 16 times 6, which work out to be a molar mass of 148.3 grams per mole. Remember that we can write the molar mass as a quality, so for magnesium nitrate, 1 mole equal minus 148.3 grams. That is a conversion factor between grams and moles. So let's go ahead and use the molar mass to the some mole conversion problem. Let's convert 6.35 grams in magnesium nitrate to moles. So we will solve the problem is exactly the same way that we convert grams and lithium. First, the write down the quality that we know 6.35 grams in magnesium nitrate. Next, multiply this by a conversion factor fraction. The molar mass of magnesium nitrate is our conversion factor because we started with a gram. Write 148.3 grams on the bottom because we are solving for moles. Write 1 mole on the top.
Half grams in the top and the bottom. Cancel out because the one is on the top in your calculator. Type 6.35 divided by 148.3. This works out to be 0.0428 moles of magnesium nitrate. First, write down the quality that we know, 0.369 moles of magnesium nitrate. Next, multiply by a conversion factor fraction using the molar mass as the conversion factor because we are starting with the moles. Put 1 mole on the bottom, and because we are solving for mass, put 148.3 grams of magnesium moles on the top and the bottom of fraction. Multiply 0.369 divided by 148, which gives us 54.7 grams of magnesium nitrate.